In today's lecture, we are going to discuss about the science communication aspect of UN's Sustainable Development Goal 6, water and sanitation. First of all, as in our previous lectures, we have discussed about the some misconceptions and the shortage of reporting and the gap of science reporting in our water and sanitation aspect. So, in this lecture, we will start with the common myths and misinformation with the science journalism perspective. Water shortage is only due to climate change. Climate change is a factor, but not the sole cause. So, we have to be careful with this misinformation. Journalists should highlight human driven reasons: over extraction, poor irrigation practices, river pollution, failing STPs, encroachment of water bodies. Balanced reporting requires separating scientific drivers versus governance failures. Common myth and misinformation, science journalism perspective, a confusion between potable water versus packaged drinking water standard. Many people assume bottled water safer, but PIC standards differ for tap water and packaged drinking water. Science reporters should explain parameters like TDS, microbial limits, and treatment requirements. Misconception fuel unnecessary dependence on bottled water when even where Jal Jeevan Mission tap water meets safety norms. We have to understand this mission, these priorities, government priorities, and we must communicate in our science reporting, because these all missions are being planned with public money for the public. How to counter misinformation in water and sustainable reporting? Use verified scientific data. Rely on CPCB, CGWB, Jal Shakti Ministry, BIS standards, IMD, ISRO datasets. Cross check claims using water quality reports, district laboratories data, and peer reviewed studies. Avoid using generic percentage and without clear sourcing. Consult domain experts, interview hydrologists, public health expert, wastewater engineers, and climate scientists. Ask experts to interpret technical reports and simplify complex parameters for the audience. Verify sensational claims with at least two independent experts. Explain technical terms in simple language. Very important aspect. Translate scientific parameters like BOD. How much oxygen dirty water needs to break down waste? TDS, total dissolved minerals or solvents. Use analogies, infographics, or simple comparisons to reduce confusions. Clarify difference between water purification technologies. What is RO, what is UV, and what is chlorine? So, RO versus UV versus chlorine, we have to clear to our audience. Track policy implementation, not just announcement. Verify on ground progress of Jal Jeevan Mission STP operations and sanitation coverage. Use RTI queries, district level dashboards, and audit reports to challenge exaggerated official claims. Regularly revisit earlier stories to see what actually changed. Debunk common misconceptions early. Clarify facts about fluoride, arsenic, E. coli, packaged water, RO devices, and climate only shortage myths. Correct viral misinformation through explainers, fact checks, short videos, or social posts. Address local myth like deep borewell water is always clean. Boiling removes fluoride. These are all misconceptions or miscommunication, maybe myth. Use field reporting and local voices. Visit communities affected by contamination, a tanker crisis, or sewage treatment plant failure. Collect water samples with lab support when possible to validate claims. Include voices of women, farmers, frontline workers who experience the issue daily, and present data visually and transparently. Use geographic information system map, simple charts or before alter photograph to show trends. Avoid manipulated visuals, keep source labels clear and visible. Share raw numbers so audience can understand scale, not just headlines. Science Communication Framework for Reporting SDG 6, the 5W and 1H approach, adapted for water reporting. What? What is the core water sanitation issue? We must understand why. Why does it matter scientifically, socially, and economically? So we have to read, understand why for scientific reasons, social reasons, and economic reasons. Where geographical specificity, district, river basin, aquifers, rural, urban, and when seasonal trends, pre-monsoon depletion, post-monsoon recharge, and who stakeholders, households, women, farmers, engineers, scientists, laymen, and how. How does the science technology policy work in real settings? How is very, very important. And storytelling models, problem, evidence, solution model. You start with the clear problem, water scarcity, polluted river, failed STP, arsenic contamination, present evidence, scientific data, lab reports, expert comments, and satellite images, government records. And storytelling models offer solutions, policy actions, community initiative, new technologies, traditional water practices, help audience understand why the issue exists and what can be done. Human interest plus scientific data. Yes, we have to go hand by hand in our science reporting. Combine personal stories, a farmer, a woman collecting water, a child affected by contamination with hard scientific facts. Emotional narrative builds engagement, data builds credibility. Work especially well for issues like water scarcity, groundwater decline, sanitation behavior, or waterborne diseases. Climate change lens. Connect local water issues to larger climate patterns, erratic monsoons, heat waves, drought cycles, glacier melt. Use IMD, IPCC, and state climate action plans to support the narrative. And behavioral changes stories. Yes, you can plan the stories who can touch the behavior. Focus on how communities adopt toilet usage, hand washing, grey water reuse, water budgeting, etc. Highlight success stories backed by behavioral science and nudges, awareness campaigns, school initiatives. Explain why behavior change is crucial for long term sanitation and water conservation. Public culture driven storytelling. Use relatable cultural references or film to anchor sanitation issues, example toilet ek prem katha, as an entry point to discuss the science and social psychology of toilet adoption, open defecation and sanitation infrastructure. Solution journalism approach. Highlight innovations such as fecal sludge treatment plant, water budgeting models, wetland based sewage treatment, or GIS based leak detection systems focusing on what works and why. And use of key national data set for water and sanitation reporting. Central Groundwater Board publishes annual and seasonal groundwater level reports. Useful for stories on groundwater depletion, over extraction, and aquifer stress. Central Pollution Control Board provides river water quality indices, sewage discharge data, and pollution hotspot maps. Helps journalists verify claims about river health and STP performance. India WRIS, India Water Resources Information System, a comprehensive water data platform by CWC and ISRO, allows analysis of reservoirs, rivers, basins, catchment areas, and water infrastructure. Jal Jeevan Mission dashboard, real-time information on household tap connection, village level water testing, and schemes progress. Support data-driven stories on drinking water accessibility and service delivery. National Sample Survey (NSS), drinking water and sanitable rounds. Provide household level statistics on toilet usage, drinking water sources, and inequalities are useful for highlighting rural urban differences and behavioral challenges. India Meteorological Department offers rainfall drought, hydrometeorological data, and climate variability trends, key for linking monsoon patterns to water scarcity and flood risk. And remote sensing dataset Bhuvan, ISRO's geo platform, satellite based assessment of land use, wetland health, watershed condition, and encroachments, enables journalists to include visual evidence and long term trends in their reporting. Tips for using data in water and sustainable reporting: use district level or block level water data to make stories hyper local and relatable for readers. Local data often reveals inequalities that national average height. And these are the tips using data in water and sustainable sanitation reporting. Cross-verify data from at least two independent sources. For example, compare CGWB groundwater data with local public health engineering department records and present data visually. Charts, trend lines, heat maps, GIS maps, and simple infographics help non-expert audience understand the issues quickly. Highlight year-to-year variation instead of relying on a simple single year's data. This adds nuance and prevents the misleading conclusions. Yeah, use government dashboards regularly, but also mention limitations such as delays in updates, self-reported data, or sensational fluctuations. Communicating uncertainty in water and sanitation reporting, avoid sensational or alarming statement such as India will run out of water by 2030. Instead, communicate the nuance which regions at risk, under what condition and why. Clarify difference between the short-term weather variability and long-term climate trends, especially when discussing droughts, floods, or charging rainfall patterns. We have to read and watch carefully about the changing in rainfall patterns, droughts, floods, what climate trends due to climate change. These kind of these differences must be clarified in your science reporting. Mention assumptions and limitations of any data set or study. Lot of studies are being going on and based on various assumptions, but many studies have some limitations like sample size, seasonal bias, urban rural gap. So any study you are conducting in any rural area maybe not sufficient data, you are not generating suitable for urban farmland or urban farmers. So be transparent about unknowns. Acknowledging what scientists cannot currently predict builds audience trust. And use scenario based language like, if current groundwater extraction continues under a high emission scenario based on present sanitation coverage. This kind of sentence can be framed. And tips for reporting drinking water issues: understanding basic of field water testing kits. Reporters should know how simple test kits work, such as hydrogen sulfide, uh, chlorine present strips, pH strips, TDS meters, or fluoride arsenic test kits. This help them interpret on ground water quality, validate community complaints, and question official data. So, intervention local health official for contamination related diseases. Health department maintain records of waterborne diseases such as diarrhea, cholera, typhoid, hepatitis, and fluorosis and arseniasis. Speaking to district health officer or ASHA worker help link water quality problem with public health trends, making stories more impactful. Cross-check packaged drinking water, complaining using Indian standard. Packaged water companies must follow specific Bureau of Indian Standard norms. And it is IS 14543, the standard for packaged drinking water. Ensure the water is treated like filtration, UV, RO, and free from harmful chemical and microbes. And IS 13428 is standard for packaged natural mineral water. It specifies natural mineral content, sources, protection, and microbiological purity without chemical treatment. Reporters can check whether the bottle carries the ISI mark, license number, manufacturing data, and testing details. Many local brands fail. Compliance an important angle for investigative stories. Follow-up stories after government announcements. Government often announces new drinking water schemes, hand pump repairs, tanker supply, Jal Jeevan mission, milestones. Reporters should return to the sites after weeks or months to verify. Was the pipeline actually late? Are households receiving regular safe water? Are laboratories testing water quality as claimed? And has the promised budget been utilized? Follow up journalism gives credibility, exposes gaps between policy and implementation, and highlights community voices. Tips for reporting on rivers and lakes: use maps to show encroachments. Satellite images, municipal maps, and Google Earth can help show how lakes and river banks have been encroached by buildings, industries, or landfill sites. Visual evidence strengthens investigative stories. Access CPCB's river data for DO, BOT, and chloroform. The Central Pollution Control Board publishes regular water quality reports. And reporters should check parameters like dissolved oxygen, means DO, indicates water health, and BOD, biochemical oxygen demand, shows organic pollution. Chloroform bacteria indicates fecal contamination, and comparing data across years help highlight trends or worsening pollution. Explain eutrophication in simple language. Describe it as when lakes get choked with nutrients from sewage and fertilizers, algae grow uncontrollably, water turns green, oxygen drops, and fish start dying. Simplifying science improves understanding for general audience, right? So you have to explain every technical term, because eutrophication is not a normal day to day language. It's a technical jargon. Now you have to inform, like many ponds, many rivers, you are just observing algae growth, uncontrolled growth, and water turns green. No oxygen, oxygen level drops, and fish start dying. So how our efforts, how our missions, what are the local bodies, municipal council, what they are doing to clean the water. Tips for rural water and sanitation reporting: document community-led efforts, check dams, ponds, rooftops, harvesting. Many villages are use traditional water system. Reporters should cover examples where communities revive ponds, build recharge pits, or use low cost harvesting methods. Excellent stories for local innovation, which is very, very important to highlight these issues. Cover water-led water committees. Women often manage household water, highlighting their leadership in villages, water committees, Jal Samitis, or Panchayat monitoring groups brings a gender and governance perspective. Map village water sources using open data tools. Tools such as Bhuvan, India, WRIS, Google Earth, and OpenGIS platforms help reporters create simple maps of wells, ponds, bore wells, and pipelines. Visual mapping strengthens credibility. And ethical consideration. Do not sensitize scarcity or drought. Avoid dramatic claim or exaggerated visuals. Stick to verified data and focus on solution, not fear. Avoid impact that violate dignity. Respect privacy and human dignity. Use illustrations or symbolic images instead of photographing people in vulnerable situations. Ethical considerations can also cover protect identity in contamination affected villages, ensure anonymity when needed, especially in cases involving polluted hand pumps, illegal dumping, or contaminated linked diseases. A skill building for science communication on SDG 6. Techniques are very important for clear science communication, and what are they? Simplify without losing accuracy. Yes, please listen carefully. Simplification is very important without losing accuracy. Dilution without distortion. Break down scientific terms, TDS, BOD, pH, STP, we have already discussed, into short, correct explanations. Avoid jargon but does not distort facts. Use plain language equivalents such as oxygen needed to clean dirty water for BOD, right? Use analogies like aquifers are underground sponges. Analogies help readers visualize invisible processes. Aquifers is underground sponge storing water. Pipelines is arteries of urban water supply. Sewage treatment is digestive system of a city, and analogies make stories relatable and attractive, improve retention. So you must invite your audience to read your story fully at one go with improved retention power. So this kind of analogies will help your article to for better reading. So break down technical content into graphics. Use simple charts, icons, and flow diagrams. Maps groundwater depletion. Show STP treatment steps visually. Illustrate rainfall versus groundwater recharge. Graphic help communicate complex hydrological or chemical process quickly. Explain why it matters for you to readers. Scientific stories should connect data to real life impact. How water contamination affect health. How poor sewage raises disease burden. Why rainwater harvesting reduce city flooding. This framing increase public engagement and policy relevance. And successful local case studies can be used for science reporting. Jal Jeevan mission cases. Mahapan village, Maharashtra. A women's self-help group managed the tap water scheme, achieving 100% bill collection and generating 1.70 lakh rupees in revenue, creating a self-sustaining model for rural water security. Warkha district, Nagaland. Communities built recharge pits, afforested water sources, ensuring long term availability, and full household coverage under JJM. Swachh Bharat Mission cases, uh, Bandri village, Yamunanagar, Haryana, 5 interconnected ponds treated wastewater connectivity, converting a 50 site into green belt treated sludge became a manure, achieving SDG 6 sanitation target and earning PM recognition. And Jodhia Badam Gram Panchayat, Chhattisgarh, became the first open defecation free village in 2 months via community led total sanitation CLTS with natural leader Balram Kashyap driving 212 households to build toilet through triggering sessions. And broader replicable models. Over 1,74,348 villages and 88,875 gram panchayat certified 100% tap water coverage under Jal Jeevan Mission, while Swachh Bharat Mission Phase 2 declared 95% village open defecation free ODF plus with waste management. These cases emphasizes women leadership, local governance, and tech like ponds, suiting data journalism on scalable SDG progress. Community-led water management case study for reporting. You can also showcase these kind of stories like Riligan Siddhi, Maharashtra, and villagers under Anna Hazare transformed a drought-prone area since 1975 through participatory watershed management, building check dams, counter trenches, and controlled trenches and equitable water sharing councils, boosting crop yield manifold and achieving flood self-sufficiency. Community-led water management can also showcase community courts banned alcohol and grazing, involving women and lower caste in planning service as a global model for grassroots development. Gram Vikas model, Odisha. Also, you can take these kind of success stories. So, this is all about the science communication and science reporting aspect on SDG 6, which include water and sanitation, which is utmost important for our citizens, and it must be communicated in an effective manner through your media outlets and your writing and reporting. Thank you so much for this session. Goodbye, and we'll meet again in the next session.